language. Afterwards we go on with Android programming, and maybe you are interested in having a look into the new part, your examination. I have given you here a document which describes your exercise that you should do this semester. It is your course-related proof of performance. If you pass this test, and I'm sure you do, then you also pass the exam. It is a application, Android application you should write here, and therefore you have some resources you should need. It is a flight navigation software. The data or the database you need, the data tables you could use, you will find in this web page. It is called Open Flights Database. The Open Flights Database is a collection of global airports, global airlines, and flight routes as well. So you have a routing database, and you can build up your own copy of this database. Doesn't cost anything, but if you want, you can donate. And this data is in a CSV text formatted style provided, and you can import it into your SQLite database. It's one part of your exam. Import this data into your database and create a SQLite database. So if you want to have some nice program, it is very interesting for us to do it with databases. So I decided to make this also a point in our lecture we will talk about, and we will try this out so you get examples, and you can use those examples too if you are new to SQLite or databases. But I think you have background information, that's why it is easy for you to adapt the knowledge about that. And the Android programmers, I think they already did stuff with the databases, because you know you don't come around. If you want to do interesting programs, you need data. Yeah, and in conjunction with the database, you need some other things. We will do this in the lectures as well. These are adapter views, cursor adapters for accessing your database, and maybe a trick, some view holders, which are quite interesting to have fast access to your data and your views as well. And then we want to try to use the query API, which is provided in Android, to have multiple table queries to make a more interesting application out of this. And how interesting the application should be is written down here. You have an example what the user would expect from your activity. It is searching for direct flight connections. If you you can imagine, if you want to go to any destination on this world, you are looking for the next airport which is close to your destination, maybe holiday destination, and then you try to find the shortest path back to your home. It is maybe a direct connection without interchange in between on another airport in another country, and because this takes you lots of time for traveling if you do not have a direct flight. But if the distance is too wide, the airplane can't fly direct, so you have to do it with a step in between. That's why if you cannot find a direct connection from your home country, destination country, you should have the possibility to make it browsable for the user, which says, okay, maybe I go over a other country and connect my flight then over maybe the neighborhood of my own country. Could be. So this is navigating in this database a little bit. It is navigating in flight routes and airports here, and so you can do it recursively because every airport is connected multiple times with other airports globally, international airports, or just national airports. So if you want to fly to a national airport which is not international, then you maybe have to use a inner country flight route to an international airport where you can go to other countries from there, to combine your connection. But it's, I think, interesting. So if you travel a lot, or if you have been traveling a lot before Corona time, then you know if you use airplanes, you are looking for maybe a cheap connection, and if you use some website to help you to find the cheap connection, then you will see there are cheap connections, but they take you very long. You have to switch airplanes once or twice. You have to go over other countries. You don't need to, and the direct flight connections maybe are not found from this tool. So here you should provide a tool which preferably searches direct flight connections. Maybe they are a little bit more expensive, but if you think you have to stay almost one whole day on any airport in any safety area where you have to eat something and sleep, and so it is not nice. So if you say, okay, if I stay there one day, I have to pay for something to eat, I have to sleep somewhere, maybe in a room where other people are too. How much would I spend for this to go? How much would it be in money? More to get a direct flight and save this time for me and save this stress. That's the idea of this application. Yeah. But we can talk about this testation in the next lecture too, if you want. So here are some questions from you. I've seen. Yeah, it wasn't easy. Yeah, that's right. So you traveled last week by airplane. Ah, okay.
Yes, I just went to see my parents for Christmas.
Ah, this is nice. Yeah, yeah. We have problems here in Europe too, very huge problems. So, if a family wants to meet the the parents, maybe of the mother of the children, and they are in another country, um, it's not the problem if they are all in the same country. So you just have to imagine you go to your neighbor country. It's maybe
Hmm.
200, 500 kilometers away. It's not so far. You can go by car. And if you want to come back, so if you are coming back, the mother doesn't have to go in quarantine. The children mm, do not have to go in quarantine if they have a negative attestation, if they have a negative test, and the father of the children has to go in quarantine. He doesn't need a test. The test is obsolete.
Well,
He has to go in quarantine. So they all drive in the same car. One person is free. The next, the children do have the need to make a test, a negative test. So, and the father, the driver maybe from the car, he has to go in quarantine. Oh, this is
well,
this is not logic. There's no logic
once I
behind.
arrived at the country, they put me at hotel quarantine for 7 days. So it was from my financial to pay, and now I'm at home quarantine still till 14th of December, which is really difficult.
Yeah, yeah, that's right. It's really, really difficult to travel around here in this time. So I
Yeah.
hope they will shut it up next year, and we
Well,
can.
I did the test. It was negative, so that's why I'm at home quarantine and not in the hospital,
Ah, okay,
which is
okay.
great. But we don't know.
Ah, very interesting.
Thank you.
Thank you too. Okay, this is your task, and I've give you time, 5 weeks time to until the 8th of January. So I think 5 weeks should be enough. If you please, if you can do it in this time, please tell me, um, and then we could move it 1 week forward. But we get problems if we move it 1 week forward because the last date is the 22nd of January. There we have we get a new colleague here in Hove, and there I have to be in another work involved. That's why we can't finish on the 22nd. I think we have to finish 1 week earlier. That's why I try to set our final date here to the 8th of January, because 5 weeks I think are enough, but you have holiday time, you have Christmas time, you want to meet your friends, your family, if so, and then this is quite tight, 5 weeks, because you need lots of time to relax as well. Yeah, in this time you want to enjoy um, the end of the year, and but the application is not that huge. It's just to say, okay, you understood what we do here, and we will have examples here as well. I think in this semester, so that you can use things and just make it running for that problem. I hope you all are able to finish this work until the 8th of January. So, but if not, please tell me. We could give you maximum 1 week more, but best would be the 8th. So please try to hold this date. Good. Then you can ask me later as well in the next lecture if you have questions. So we go on with Kotlin now, and we have been starting with classes and objects last week, and there we go on now. Okay, let's see. Classes and objects begin here. So we're talking about classes without a body, or constructors as a method name with a keyword constructor. We have seen the difference between primary and secondary constructors and the init blocks in combination. And what have we else just figured out? We have been talking about different classes members. We have seen there are object declarations, which are quite a little bit new, but we can imagine what those object declarations are in Java. They are anonymous classes, anonymous inner classes. That's why those object declarations only exist inside a class or a method somewhere around, and we have only private access to those objects. This is a limitation from Kotlin. If we give those anonymous objects out of a function, we get it cast to the any class. So there will be the top level data or class type any of this object. And we only have private or local access, so it's just a small local solution, as the anonymous inner classes in Java are too. Okay, other things, inner classes have the keyword inner to connect the inner class with the outer class, or if we leave the inner keyword, we have a static inner class, which can be where objects can be made of without the need to have the existence of a outer class object. Therefore, and we have been showing this as well, the access of named attributes which have the same name in those different scopes, in the outer class scope, in the inner class scope, functions or methods and attributes named in the same or having the same name. We can access them with a tag, so it is the class name with the @ sign followed by the variable name or method name, then we have access to the inner or outer class. We can do it with the superclass as well if we have inheritance, and inheritance is simple too. In case of inheritance, we have access to the superclass as well with the super keyword, and we can access methods and attributes which have the same name in the super type as in the special type, with the super add tag annotated, and then we can solve or resolve those overridden variables and access them as we usually do it in Java 2. The only thing is we have a new base type, and that's why all types are object types. The primitive types do not exist anymore in Kotlin. We just have object types here. Okay, new is that the parent class has to indicate inheritance. This must be done by maybe the open keyword. And if we go forward to, that's what we are doing today too, if we are going forward to the abstract classes, then the abstract keyword includes this open. The mean of open is absolutely included in the word abstract, because if a class is abstract, you aren't able to create objects from this class directly. You need to inherit from a abstract class, and that's why the abstract keyword is open per default. We will have examples with this today. Okay, derived classes use this colon here to say this object is derived from a base class object. And if we want to redefine attributes or methods, we have to open them as well, and we have to say this is a override or it is a final override maybe of this attribute or method. So the class must be open to derive from the class, and the attribute or method must be open to redefine or derive from this attribute or method as well. That's what we have shown in our last example, I think, but we can start a new one just to repeat the things we have learned. So imagine we have a base class called class base, and we cannot inherit this class base since it isn't open for inheritance. So if the lower class, the subclass of the base class, isn't possible to do because the base class is not an open class. This type is automatically final, so if we do not have to write it. So you see this IntelliJ idea, I don't know how to make the everything a little bit bigger. How to make it bigger? Let's see, maybe we get the editor a little bit greater with the text. I think it's somewhere in the settings, and maybe we can change the size of the font. Here's the font, and we give it a size of, maybe it's 13, I give it a size of 17 and say apply, and I think it's much better for you now to see this and for the recording as well as the stream. So we can't derive since this class is final. The final keyword can be omitted because it's final per default. And if we want to derive from this class, we just open it. Now we can derive from the base class, and if we have a attribute in the base class named attribute, and maybe it's a string with the value base string attribute, we can redefine it in this subclass, but if we do so, it is wrong because it is not initialized, okay, or should be abstract, so we initialize it with subclass string, but still there is an error. We have to mark it as a override because it hides the super member. So if we mark it with override, it's still wrong because it isn't wanted that this attribute could be overridden, since we haven't opened it. We didn't open it up. But if we open it up, we are able to override it. The same with functions. We have more control on the extension of our classes, since we have to define which parts of this class are open for derivation, or which content of this class, with which class members are not open for derivation, and they may not be derived. So you can't derive this attribute and maybe just some methods. This is then a open function returning maybe the attribute in a lowercase manner. And then we can have foo function redefined. Therefore we need the override keyword and could say this is the function signature. The return type is given with this colon directly after the name and the parameter list, and then we can say, okay, I want to have this attribute in uppercase. Now we can have a base object here and use the function foo from this base object once, which prints a lowercase string, and the other idea was to say we use our subclass object and use the foo function in the subclass object, which uses a derived version from this foo function, and we can have it automatically print a uppercase string. Once I have to, yes, I know I am in the third, I changed it already into main kt3. Now here you see base string small, base string in uppercase, and that's what happening here. If we try to test the polymorphism, we should write a other print function. It would be some printout, and we accept base objects. So we have a object of type base, and you all know we can use both types with this method now, and then we just print line the foo method, since the base class is able to call this method foo. It can be called with a base type object, and the polymorphism should use the special function if we give a subclass object into this printout method here, then the foo version of the derived class, the most special version, should be called. That's why we try to change this to printout here and see which version of foo is coming out from printout. And as we expect, it should be working with polymorphism per default. So the same approach here. We all know this is called polymorphism. That's why we can use all those objects here which derive from base, and if we call a method, we get the most special version of this method through overriding. Okay, that's for the repeat of our stuff. Then we were talking about the inner classes, and here we had the possibility to access things in the outer class. Super add and the class name gives us then the access to the outer class here within the inner classes somewhere. And if we want to try to figure out how the abstract classes work, then we just use the keyword abstract, as we know. So if I have a abstract base class, I just want to change this to abstract, or maybe we make another base over the base. It could be abstract class my base. Now it is a abstract base class, and we should derive from this my base and have to call a standard constructor here. This class has a constructor, but we can't construct objects from my base since we have to derive from that. This keyword just says, okay, this class is you have to derive from this class. In Java, this makes sense as well. We can have abstract classes, but we need some content inside. Here we can leave it away. This content, we can just define this class as a abstract class, and to use objects of this class we have to derive from it. Now we are able to change the printout function to my base, but if we change this, the function foo is unknown, and therefore we should define a abstract function as well. So abstract fun foo should be there, and this is a function which returns actually a string, and we do not need more, just the signature, that's the name and the return type of this function. And then let's say, why is there an error? And here it says foo hides a member of supertype mybase and needs override. So here we have the override. Before we had this open keyword, now it doesn't, we don't need it because it's not, we can have it open, we can leave it, but open is not needed. We override it, and this open, you see, is just a word which is obsolete. We can stay here, but it's not needed here. We can leave it out. Okay, you see this as the final keyword before we had here a final version. This final keyword can stand here, but we don't need it because it's final per default. We have to open it up or leave it maybe without a keyword, and then it's final. So, and that's why here this would be final, or if we override it now, it is open. So this abstract is automatically open. Abstract is open automatically, so we don't need the keyword open because it's abstract. The class 2, you see this. I derived from this class. I do not have the need to write the keyword open. If I write open, it is not a problem. I can write it too, and it's not grayed out as well. Could be grayed out, but what's wrong would be final. So this is it's contradictory, and this is not compatible with each other. So I close this class for derivation, and here I say you must derive from this class to get objects from. So it is a absurd class here in this case. That's why we may not write it in this way. It's not possible to do so. Okay, we go on. Oh, this is the abstract version now from my base, and we have the function foo, and now everything would be fine. So it is safe that all derived classes we have from this MyBase are suited with this foo function. Here, in any version, every class has its own version, and the program should run correctly and give the same outcome. This is Kotlin programming. Somebody's asking here in the stream chat. If you have questions, please ask. Can we use other databases like PostgreSQL or MySQL? You could use other databases, but Android supports SQLite, and it is a SQL database, so the querying is almost the same, just a special API. You have to use objects to query, and normally there isn't a PostgreSQL database available on the Android phones, or it isn't accessible over the Android API, so you should use SQLite. But it's simple. It's a SQL database. If you do the exercises, you will see this very simple. Good. Okay, this was a look into the abstract classes, and then we have maybe what do we have? A static method is the next point. Static methods, and Kotlin doesn't know the keyword static, so static methods aren't known to Kotlin, as we know that from other programming languages. We only know here some things which are mapped onto static classes, static methods, and static members in Java. So if we program Kotlin for the Java virtual machine, we maybe get some static things in this bytecode, but if we program in Kotlin, we won't have a static keyword to say this is any static thing. We know the companion object already. A companion object is a statically available object, what we can access from the global context without the need to create a object of this class first. Like me can access a game that is sure you can access. You can. Okay, and we have only another thing which should be then a static version of a method, and this is the top level function. So what Kotlin is able to do, it gives us the possibility to use top level functions, and where we see it is the function main. This is a typical top level function. And if we think about how can we run this top level function if we program for the Java virtual machine, the Kotlin compiler has to surround this main function with a class body and has to make this function static. So we don't need a keyword static fun main. So if we do this function on a top level, Kotlin creates surroundings for this class if it makes a actual Java class out of this, and to run it with a Java virtual machine, and this class then has the public static void main inside, and therefore the virtual machine of Java is able to run this class. Without the public static void main, the Java virtual machine wouldn't be able to run your class that you compile with Kotlin. Okay, And those top level functions, we can have lots of top level functions. This is top level here as well. So you see, on the top level we have functions, we can call them without the creation of any object, but we do not need any static keyword, and especially the methods here inside those classes can't be annotated with the keyword static because it does not exist in Kotlin. Yeah, we can only think how would Java do it, and we can only imagine, okay, this should be a method of a class in Java which is then static, but only if we make this code run in Java or in C++. Yeah, all other things are not static here. So these are the top level functions, and if we use a companion object, we can call the methods via the class name. Here somebody asks us if C++ is a good starting point for programming. I would say every language which is similar to C, C++ or Java is a good starting point. Yeah, therefore you could start with C++ too. Yeah, it's not a bad start. It's quite a good thing, I think. But it's not the easiest language for a beginner. But it's nice too. So you learn a lot if you try. Let's make an example with this companion object here. As next, we have the need to put it somewhere into those classes. I could say if I put it in my base and build up a companion object called my object, and let's say inside this object we have a maybe value, my value, maybe an integer number 10, and then we can access this value over the class name and then my object, because it's existing in this class without the need to create a object of this class my base first. So we can access it over this my base. My base is extra abstract, but normally we should have access to my value. And you see, what is my value? Why I don't have to write my object name in between. This is something Kotlin makes possible because this value is here accessible statically in a static manner. You know, there's just the class name. We haven't created an object before because we didn't use the constructor. We can't use a constructor for this abstract class. That's why this must be a static access to this value. Therefore this value should be a static value. So we are able to create static things without the static keyword. That's the approach, the outcome here. And what we don't need is the name of this object. We can leave it away because we can access it directly as a static part. So in Java we could write here the static keyword, and here we write companion object. Okay, and this is the solution of Kotlin, to have maybe something static inside a class. If we want, we could as well give this object some methods, and those methods would also be static. So if I have a method, let's call it foo, or first we call it bar, and we call it bar and give it a value returning -1 here. So can we access bar now is the question. and we want to print line what my base bar gives us, and we see we have access over the class name into this method, can call it, and we get the value -1 delivered. And the next interesting thing is, what would be if I call this method here foo? Can I call foo then in this way? So we have two versions of foo now, one version repeating a string, another version repeating a integer, and both are accessible here in my base. And this is an, you see here now we have an error now, unresolved reference. Okay, it's like bar. It should work in this way. So this is the static version. We can access it directly and get this version. And the other versions of foo we access over the object are still those string versions. We could say, okay, let's make a string version to make it more complicated. Okay, and we give the string -1 back here. And can we do it now? And we can do it. It's the same. So here was another question with all the variable of Java. I don't understand your question. Please precise your question. Okay. So Kotlin is very, very good, the compiler, to distinct between or make a difference between those two functions. They are named the same, but they are in a different scope. We have access over this class name, and if we do it, we just access the static version here, and we cannot access the non-static virtual version of this function, because since it is abstract, it is a pure virtual function. You know those pure virtual functions maybe from C++. They are only abstract, and then we have to override it here, and we get the polymorphism for the function foo if we access it over an object. If we do here a other thing and would use my base, or maybe let's try to use this my base foo over the derived class, since we derive from this class, it should be accessible over the other class names too. Let's try to use only the base class, and has the base class access to foo, and the base class has no access to this static function foo. So the static function foo is only available for my base. It's not derived. So could we derive it? No. Yeah? Can't derive from this companion object. So the static part is only accessible over this class name, and we see it is not derived to say, okay, I can access the same static methods over another class name, and it makes sense as well. Okay. Questions so far from you? If not, then we advance to the next point, to our next slide, and we now want to focus on properties and property setters and getters once a while. And first we have a look how to declare properties. We know the keywords variable and value. And if we declare a property as a variable, we get a setter and a getter. And if we do it as a value, we get only the getter method available. And we can access the methods directly over the attribute name. If I write object reference point name, I access the attribute name with a getter if I read from this attribute, and with a setter if I write to this attribute. If this attribute is not writable, there will be no setter that I can access so far. So getters and setters will automatically be used when I access the attribute, and we have then something similar like public access. So just say goodbye to this example here, and we start a new one. Now we focus on properties. Maybe we have a class my having some properties. We could write this class my like this, a value name, maybe a string, it's my name, and I call myself Christian. And if I want to see this name, I can access this name. At first I need an object of type my, so I just try to create one with a standard constructor here. So you see, this is a constructor call. It says take this class, make an object, save it in this attribute, or save it in this value. It is not rewritable, so we cannot lose this reference as long as this value exists. So it exists in this how's it called, in this scope. It exists in this scope here, and if we leave this scope, this object will be unreferenced afterwards, and so it can be deleted by a maybe Java garbage collector. Or if we create C++ native code here from Kotlin, this would be a object reference too, and the reference is deleted automatically if we leave the scope in both languages. So it's compatible to both Java and C++. What Kotlin can create here, it's very amazing. Now we want to access this value. You have already seen it in several examples. We just focus again on using the getter method. And if we want to use the setter method, then this attribute must be variable, because if we want to access it in this manner, it just gives us an error here. So since it is a value, it is not mutable. And we don't have a setter method. So to make it accessible, we just write variable here. Now the code is able to provide a setter method. The setter exists, and we can use the setter here. So now this example uses the setter method to change this name here in maybe John Doe or something like this, and it just uses the setter. We can have a own setter or getter method, so we just go on to the next line and define a get method returning a string, and it must return this name, maybe to uppercase, here, and then we have a well-functioning getter method. So if I print line this object name, you will see it with a big letter. We have a moment. This is a if we access name, we have to access the field value. It is called a baking field. Now you've seen the reason why we need a baking field. This is here called field, accessing the attribute with its name always uses the getter method. So if I write a special getter function and I write return name here, as we would expect in Java, we access the getter. So this is name is the get method again. This is what we get. If we write name here, the getter method is substituted here, and that's why we get a recursion. And this is what you see. This is the typical approach. We have get name. You see my get name. This is what Kotlin creates. It's a method called get name, as you would provide it in Java 2. If you program Java, you would write a getter for the name attribute called get name. And this method, my get name, now calls itself recursively, since it will be called, this method get name is created, it will call itself, and therefore to come out of this recursion cycle, this endless recursion, to stop endless recursion, Kotlin creates a so-called backing field named field. And if I access it over this backing field, I get no recursion. This is a copy, actually a copy of the value of this name. Or a reference. Better to say it is a reference. So I have a reference to this value, and I can use it in the desired form, and now we don't have a endless recursion here, and can access our get method, our self-defined get method, and get the name in uppercase letters. And the same is, we can do it with the set method, but in the set method we have to define a attribute 2, so we could define a name which is a string, and now we have this problem, if the same problem again. So how is it problem if we say this is name? We here call the setter method, and now the setter method is in a endless loop, and that's why we just write field here. So to break this recursion, we have this backing field called field, and that's the choice we have to use if we get write own getters or write own setters. So field is name. This is the same. This is an obsolete setter because we do nothing with this name, and we should do field to lowercase, maybe, to say okay, it makes something else with this variable, and if but it's only this okay thing. We will never see the lowercase letters since we have a getter which makes uppercase letters, but we can say okay, leave this getter, leave it out, and just try to see what the setter method does. So if I rewrite the name and print it afterwards, you will see everything is rewritten in small letters. So the first version I've given directly. Okay, the other thing isn't rewritten. Moment. Field is, I have to set it like this. So I could say field is named to lowercase. This is better than I just have to write one statement. Now we get it. small case in a lowercase fashion. Okay? This is the getter and setter, and we can say, okay, make this setter private. If we want to have a public getter and a private setter, we are not able to access this variable. So if we have a value, we do not have a setter method because we can't write it. I could write a setter for a value, but it will not work because this can't be set. We have no backing field, we have no name attribute changeable. We cannot write a setter method. If we want to have a setter method, we have to write it variable. But if we want to have it changeable here, but only readable to the outside, we can just change the modifier or append the modifier and say it is a private attribute or it's a private method. The setter is private, the getter is public, and then we have the possibility to have a variable attribute, but it's only readable to the outside and not writable for the outside. So if we want to have a private setter, we could just write private set. Don't have to redefine it. We can leave it out. The compiler is able to see, okay, this is private and this here maybe is public, and then we have a public getter and a private setter or any other modifier. So this won't work since the setter method is now private. Have you any questions so far to this check? Okay, let's have a look to the next one. This was getter and setter, so we can have variable property type property initializer and then getters and setters. As we have seen too, if we want to have this here in a primary constructor, just write one. The primary constructor is allowed to have this variable here, but then we cannot define own getters and setters. That's not possible if we do it here in the primary constructor. There. If we do it in the if we want to change the behavior, the default behavior of getters and setters, we aren't able to use this in the primary constructor. We have to do it in the class body, but it's easy. You've seen it's easy. This is the default behavior. If it is variable, you have setters and getters can read and write this attribute. And if it is a value, you have only the getter and can only read this value. Okay, let's advance to what do I have? I have here some interesting. I have another interesting example. We could add a value or variable, or first value string representation, and this string representation is a string, and this string has a get method, and this get method is defined as this toString. Now my class has a string representation, gives us the standard string, and we could write now a new object and ask for the string representation. If we print this out, we get a toString version, and it is returned from this get method. So this is a attribute. This attribute doesn't have a value itself. It just is it just has a get method. So if we access this value in a for reading, we can only read this because it's a value. If we access this attribute, we get the getter method called, and the getter method delivers us the toString here. So we do not have a baking field. This attribute does not have a backing field. There is no class, actually no class member, nothing in memory which holds this string, because there is no string in memory. This string is coming as return of this method here. So there is no backing field. But we still get this string representation, since there's the toString method. And if we redefine the toString method as we know it from Java, because we derive from object, and object derives from any, so we derive from object if we have a class. This object has the toString method, and we can redefine it because the string method is open in the class object, and the class object is open per default. And now we get our name back. This is how it works, but it's fine, I think. Really fine. So backing fields are automatically generated when needed. In this approach here, we don't need a backing field, and then we don't have one. This variable here is really existent. It has a value, and this value has to be present in memory somewhere, and that's why we need this backing field to hold this value. If we access this attribute name, we access actually the getter method, and the getter method returns the values stored in the backing field. And if we access the setter method, which is automatically generated to here, we can pass a value to the setter method, and the new value will be copied into the backing field. But here we don't get a backing field generated, because it's only generated when needed, and we don't need one. Next thing is we have compile time constants. In Java, you know the final keyword we have already talked about. If you make a attribute value final, it is a immutable variable, and this is what we have with the value keyword. So what Java says, a final attribute is the value here. So if we have a value 5, then this is a constant. This is a similar to a final int. In Java, we can't change the value. So we can't do this. You already know it is not possible. So this is already a constant. But this is a constant during runtime, because this could be the outcome of a function which returns some cryptic thing, maybe some random number. Random next int, and this class random, I have to import it from Java util, and then we can have random next int, and this is called maybe my random. Then we could have here a random number, and it still works. So this is a similar to a variable in memory which holds a value which is created at runtime. That's what I wanted to show you here. This value that this number here holds is created at runtime. We can't change it afterwards. It is constant in memory and we can access it. But the value is made at runtime. If I write the keyword const here, it is wrong. Okay, it says it's not applicable to a local variable. If we try to have it here, and we can't call my random because this number, this keyword says it has to be constant at compile time. Const means constant at compile time. And this is something Java does not have. Compile time constants is maybe the number 5 is 5. This is a expression which can be evaluated at runtime. It could be like this too. The compiler is able to take 1, add 1, add 1, add 1, add 1, makes 5 out of this. If we say, okay, this is a constant value, compiler please calculate what its value should be, then this compiler is able to create this value. And everywhere I use this symbol, I get this value copied there. It is maybe never in memory. So this is maybe never a field in memory. It could be a number which the compiler is able to calculate, and this number is then copied on in every expression where we use this 5. So if we then later have a number which uses random, my random times 5, then the compiler will be able to change this line of code into this line. This is something like in the C programming language the preprocessor is doing. He's doing some macro substitutions, and that's what is possible if we annotate anything with this const. Then we say this expression can be calculated before the program is started, and that's why the compiler is able to calculate this expression and give this attribute its value. And moreover, it is able to say everywhere where I use this attribute name, the already calculated value can be substituted to make your program run much faster. So this is a new thing, and I think it has come into Kotlin from the C++ language, because those compile time constants are const expressions in C++. So I think this comes from const expression in C++. But it's only what I think. I don't know. I would have to read it. But we know it's a compile time constant. This is clear. Now this works, and we can have it here, standing here. If we do it down here, it isn't correct. It says remove this const modifier because it's a local variable. A local variable won't be constant, so it will do it here. Normally we have constants like maybe pi and say it's 3.1415, and this constant is a real constant, and everywhere we write pi, we then get a faster program, because this can be substituted. Yeah, that's what's done here. Have you questions so far? Okay, then we can run it now with the constant pi, and we get a random circumference. So the circumference of the circle here was negative. Why? What is it negative? Shouldn't be negative. Once again. Negative again. Okay, let's see what my random produces. It's a positive number, but if I should make a to double times pi, and I should say this is a double 2, but it's clear that is a double. Maybe it's an overflow, I don't know. I don't know why this is minus. This is really amazing, because we get a random next int. Let's make some smaller ints here. Yeah, better. It isn't negative. Those integer values have been too big, and now we have bounded with an upper bound, and the numbers are now smaller. So this to double is not needed, because since we produce a since we multiply this integer number with this double number, it will be automatically switched into double here, and since this here is a double number, we don't have to write it here, because it stays double, and now we have our positive solution. Okay, guys, we go on, and what we else have is late initialization. This is, you maybe know, if we create a class object and we don't know the value of this variable name, we are actually not able to create it. So if I want to create the class myObject now, I can't do it. So I take this away. We just focus on this class now and try to create an object of this class. So standard construction is not possible. We have to give a default value. The variable needs a value. Name needs a value. If I do name here, you will see this more clear. We have a standard constructor now. We can leave it as a standard constructor, and the compiler says, hey, you have to give it a value, because null pointer safety. This is the argument. We want to have null pointer safety. So it's not possible to say, I don't know the value, I say I give it null. If I want to have this, I would say, okay, this is a nullable value. Now I have the standard Java solution. I create a class object, and I don't know the value from the attribute. In this moment, when I create it, I just create the object with an empty value. But then it is a nullable value here, and that's what we do not want. It could be an integer as well. We don't know the value of this integer at this moment, and we don't want to give it anything. A random number maybe. We want to give it only the correct values, and we don't know the value at the creation time of this object. Then we either would have to eat this null pointer and to change our code into a null pointer carrying type of code. So if we access name and do something with name, we can't use functions that accept integers which are null pointer safe. So just if I want to print this int and accept a value of type int, value should, I don't should use the keyword names. Then it is not possible to call, is it called name? So I call it value now. I'm not able to print my value because my value could be null. So I want to create this object without defining this value, but I don't want this null pointer. I want a null pointer safe value, but it should be initialized later. So I write here late init. Then it could be initialized later, but it's not okay. You see, it is not. It makes no sense with the primitive types. So at least it should be a string. So we print the string. We do it with the string. So, okay. It says this value comes later. It could be initialized somehow later, maybe with a set method or with a init block, which says value is simply nothing. So, but now this is initialized during object construction, and you see automatically it is grayed out because this late init doesn't make sense now. Now it makes sense, and we can print the string. We can try to, but it will fail. As we know, if we must take care very much, because now we have a uninitialized property access exception. The late init property value hasn't been initialized. The Kotlin compiler is able to track the initialization, the first value initialization of a attribute property. It is able to track this, and we can check if this property is initialized if we access it with is initialized, or my punct, or is initialized. How it was, I don't know. It's a long time. It was quite a long time ago since I did this Kotlin last time. We can get this property factory somehow, and then we have the possibility to get some meta information about this value, and therefore we can ask if it is initialized. But I don't have a special example on my printouts here, so I would either show you this next week. Better to show you this next week, then it will work. So we can respect this late init. Maybe we set it with a method or something like this. Just have another function, or initialize it before we have public access. Initialize it before we print the string of my value. We set it. Now it is initialized and the program won't crash. But we have to take care about initialization by ourselves. Before we use it or access the getter method of this property. This is important. There is a solution. It opens up. It makes it a little bit risky for us to use it. So better not to do it like that. but sometimes it is um, needed in case of objects which access maybe data fields in a database. You create the object and the object is fetching itself, so you maybe have a fetch method which only works after you decide to a fetch method which only works after you create the object. Because you fetch it from a database, you need to have a ready created object. You can't fetch it in the constructor because the fetch method could fail and produce maybe a connection error, and that's why you should construct your object in several steps, not only in one. And it could be then not possible to initialize all the attributes, so you have late init things here and you can construct it in several steps. Okay? This is a possible approach where you would find this. But since you have here a string, we could say, okay, initialize it with a empty string, and this is a default value, or it is a string called undefined, which is a better approach than to use this late init. So if you are able to come around without this late init, do it. Yeah, you try to define a empty object or a undefined object of your class. It could be a companion, or just a object called empty, and this empty object would then be used to maybe my empty object, and the value undefined. Okay, constructor call, good. And this is member declaration, so we have to set it in the constructor to undefined. Maybe we write a constructor here and set the value to undefined in a constructor, like this. Have we access to this value? Unresolved reference. Because of this type is final, we can't access it, and the constructors are not allowed for objects. Yeah, this is a problem. Okay, it was just a try to think about what could we do to define a empty object of this class inside this class, so that we have the possibility to do so. We maybe should define it as a companion object then, and have and have it somewhere as a empty object of this class, maybe. To say, okay, from class string, I say there is a empty string, or there is a empty my object, which is used if I do not initialize it. So now we have only 5 minutes left, but I want to go on to the interfaces as the next point. It is really simple because you all have already programmed interfaces, I'm sure, and that's why we just use this keyword as we know it from Java and have a interface. And this the only other thing to Java is we can have implemented methods in interfaces already. If I create a interface for my data, now I have a interface, and this could be implement my data interface through normal derivation, so I don't have the need to say, okay, I have a extends keyword, I have a interfaces implements keyword. I just extend or implement this interface through this derivation here, and now my class has the type my data, and I can print my data, as you know. Before, the abstract class approach was similar, but I only have access to the attributes and the methods in data. That's why I should give here some methods. Interfaces are nothing else than pure abstract classes with pure virtual functions, but here we have the possibility to define functions as well. So we need a function, and this function does not have the abstract keyword because it's abstract. Why? Since we are in an interface, we have the function foo, maybe returning a string, and it is giving us this toString. So this is a function working with the data object, and we have this function which has the toString value, and I can say, please, you have to override the toString value, so the function toString has to be overridden by every class that is yeah, it needs override because it's a override. Okay, and then it is here needed that the class my, you see that the class my has to override this function now, because there is no function body existing in the base class my data. So this is a interface. I derive from this interface, I implement this interface in this class my, because this class keyword says you are allowed to create objects of this type, and you aren't allowed to create objects of this type. But since I derive and I say this should be a class where I want to create objects from, I have to give the compiler a function body according to this function, and then I just override this function and say what's the outcome here, and this is the value. And now I can call the foo method, which has actually a working function body, or is a really running function, and I can access the foo function here, and all classes that implement this interface have to override the toString method this way. So now I print here my data. And we see the value is presented as expected. Have you now any questions at the end of this lecture? So it's quite interesting, this language and how it works, though what is behind those keywords is quite simple, because we can produce code for C++ and Java. We have to rethink some special solutions in Java which aren't possible to solve in C++. And in C++ we do know nothing about interfaces like Java does. We only know the abstract classes. So this interface is nothing else than a abstract class, and we have here a abstract function toString, a class, class, and we have here a abstract override function, and then I can derive from my data. But the difference now is this is a class, and a class has a constructor, and therefore I have to produce a object. I have to connect the subclass constructor with a superclass constructor. This is the only difference. So we have the same example now as we had before when we were writing interface. So writing here interface just leaves out construction of the base class object. Therefore, I have to write interface, and if I write interface, the methods are abstract per default. I don't have to write abstract. It is not allowed here to write abstract. Yeah, and interface class is also not good. So that's why we just map the interface on a abstract class without the need of a constructor call here. This was all. But we must be compatible with the C++ language. That's why there must be a mapping, a possible mapping to a abstract class in C++. Yeah. So, and now you see what we got from this. We are able to produce running code in a interface, and we just don't have the need to write abstract here, because in Java we don't have the need to, so it's not needed. It's an interface. Everything is public and everything is abstract. Good. Now we have 2 minutes more done than needed, so but you get 15 minutes break now. So we start maybe at 11:35. I give you some more minutes break. 11:35. Then we go on with the Android. Thank you very much for listening, and see you in the next lecture.